Alright, welcome back, Math 9. Today's lesson will be not from any of a booklet portion of your duo thing. It is more from your, improv questions and then followed by some textbook example. So I want you to, sorry about that. I want you to take out the blank pieces of paper. Or if you have a math notebook, that's perfectly fine because I'm using my notebook like this too. Today's lesson title is called Polynomials BEDMAS Part 1. The reason that I like to call BEDMAS Part 1 is because we are doing only certain segments of BEDMAS, which is bracket, addition, subtraction. But I'm going to differentiate few things compared to last time. Number one, some modification that I'm going to do is highest degree will not stop at second degree. Highest degree will not stop at second degree. That means you will see cube or to the power of 4, those kind of nasty example, if you will. But we can still use our skill that we learned, ladies and gentlemen. It's not something that you don't have to freak out. And another thing is, we may have more than 2 expressions, which is a fancy way of saying we're gonna have more than something and minus plus something. It's actually a combination of, it can be adding, subtracting, or adding and subtracting, or subtracting and adding, variety of type. So have that in your mind. We are gonna do a lot of classroom example, so please consider that part in your head. First thing first, let's deal with our classic example. And at this point you may notice polynomials are all about the practice. It's not something that you can memorize other than some of the stuff, but have that in your mind. And know the fact that I'm not going to use drawing method. I'm going to do everything as a mental math method. So, ladies and gents, we have, and this is precisely the reason why we cannot use any type of diagram, is because, can you see that exponent over here is to the power of 4? When it comes to drawing method, you can use for square, so second degree, or just by itself, single degree, or nothing, which is integer tile, and that's basically grade 7 and 9 stuff, using integer addition and subtraction. So, when it comes to this one, fortunately, we know that it's addition. That means I don't need to change any sign. No sign distribution is needed. Which is a fancy way of saying we can just rearrange some of these guys with the like terms. And the way that I can do rearrange is always find any of the terms with same degrees, like terms. That's what I want you to understand. And I want you to group them together. So let's give it a shot. 6p to the power of 4 plus 5p to the power of 4 minus 3p to the power of 2 minus 2 minus 8. As you may notice, when you rearrange, I still go through descending order. Highest degree to lower degree. Once that happens, group them and do the calculation. Positive 6 plus 5, that's 11p to the power of 4, minus 3p to the power of 2, negative 2 minus 8 give you negative 10. And that's how you do, folks. As you may notice, it's quite clean it's quite clean in terms of how the organization is going if you rearrange everything. And I know in high school we generally can skip this part, but still I encourage you guys to write it even when I was teaching high school kids, because that's where the most mistake can happen. Let's go through the second one. This time I'm gonna mix it up, and it's gonna be 3 different terms. So first thing first, people freak out because of 2 reasons. Number 1, it's no longer a pair now. It's actually 3 different expressions. And number 2, 3 and 5, it's not in descending order. Then here's what we do. Like what we learned yesterday, we are going to apply a little bit of change, but focus on each expression that include or affected by the negative sign. So as you may notice, I put a little dotted line. This is my expression 1, which is unaffected. Expression 2, which is affected by this negative sign. And expression 3, which is again similar as the middle term. You are affected by negative sign. So that means sign distribution is needed. Do not get lazy at this point. Write everything. Even though it's a long step, as you may notice, we write every single expression, and then what you need to do is rearrange. Like for example, I have b to the power of 3, b to the power of 4, so it's a good idea to rearrange in a descending order. Negative 7, b to the power of 5, minus 4, b to the power of 5. So these 2 are done. And you can check if you want. Positive b to the power of 3, negative 2b to the power of 3, minus 6b to the power of 3. These terms are gone. And 3b is the only single term. And that's already good to go. It's already simplified. And then plus 5 minus 9 minus 8. So what I need to do is do these 2 calculations, these 3 calculations, that one's already good to go, and these 3 calculations using the process of BEDMAS, which is left to right at this point. Negative 7 minus 4, that gives you negative 11. Positive 1 minus 2, that's minus 1. Minus 1 to minus 6 is minus 7, b to the power of 3. Positive 3b was already good to go. 5 minus 9 was negative 4. Negative 4 minus 8 is negative 12. This is how you deal with any question, polynomial, addition and subtraction, random, and if you have multiple type of like terms, this is how you do. I understand as a student that I really like to skip this section, but I'm telling you, as a grade 9 student, you have to give it a shot, go traditionally, one step by step, and then once you get very used to, that's when you can omit the step. And that generally happens in grade 11 or 12. All the way then, even grade 12, when you do the written response and diploma exam, you better have it, actually. Alright, example number 3. This time, why don't we put some random example. There you go. find out or divide each of the term and figure out which expression are already good to go without distributing. First one's good to go. Second one's good to go. Third one, we gotta do our negative sign distribution. So, once you figure that part out, I want you to write down, so basically rewrite, before rearrangement, 6 minus 2x to the power of 4, 4x to the power of 2 plus, the second term is unaffected. Whatever the sign that you have, you just bring it down. Third one is affected. I gotta put opposite sign of everything. Negative and positive, that give you negative. Negative and negative is positive. Negative and positive is negative. There you go. Actually, this question sign, let's get rid of. And I want you to put like terms together. We have highest degree, which is to the power of 4. And there's only 2. Next highest, cube. Next highest, and then our constant term, positive 9, minus 5, minus 9. Order at this point doesn't really matter as long as it's left to right. So, like terms together, and we do the simplification. Negative 2 minus 1, that's negative 3x to the power of 4 plus 10x to the power of 3 plus 12x to the power of 2 plus 6 minus 9, that's negative 3. Negative 3 with negative 5, that's negative 8. As you may notice, we can simplify this term into just saying that instead of adding by negative 8, just put minus 8. That's how you can tackle this problem. Now last part, even though quite a lot of students may already figure out the method now. Last part. Yeah, why not? Let's use the variable a. First thing first, some people think that Mr. Kim, I don't have any bracket. Does that mean we have 4 term? 1, 2, 3, sorry, 4 expression. 1, 2, 3, and 4. Yes, you're right. So I divided into 4 big chunks. And then figure out, is there any term that have a distribution problem with the sign? Yes, we do. The one with the negative in front. Then we gotta get some change in here. 7a plus 6a to the power of 4, that one's just the way it is. Negative 8a, negative 5a to the power of 4, minus 9a plus 4a to the power of 2 plus 3a to the power of 4. Rearrange everything. For the first time, we have highest degree that has more than 2. I omitted positive because it's at the very front. Plus, the next highest is plus 4. And then positive 7a minus 8a minus 9a. There you go. Then we are going to calculate these three like terms. Oops, sorry. That one's already good to go. There you go. 6 minus 5, that's positive 1. 1 plus 3, that's 4a to the power of 4. Plus 4a squared. Plus 7 minus 8, that's negative 1. And then negative 1 to negative 9, that's negative 10. A. Simplify the sign, which is these two. Instead of just showing plus negative, just put negative 10a or subtract it by 10a. That is today's lesson, and I'll give you the homework question.